On this slide, I want to talk about three important theorems. So first we do a quick recap. So recap is sine theta is 0. This implies theta is equal to n pi, where n is an integer. So n is 0, 1, 2, 3, 4 or 0, minus 1, minus 2, minus 3 and so on. And cos theta is equal to 0 implies theta is equal to 2n plus 1 times pi by 2, where n is an integer. So now let us write down the theorems. Theorem 1, sine theta is equal to sine phi. If theta is equal to, if this equation holds, this would imply theta equals to n pi plus minus 1 raised to the power of n times phi, where n is a integer. So sine theta equals to sine phi implies theta is of the form n pi plus minus 1 raised to the power of n times phi, where n is a integer. So proof. So first we write down sine theta is equal to sine phi implies sine theta minus sine phi is 0. So now we use those formulae, the difference formula. So you can write sine theta minus sine phi like this as 2 cos theta plus phi by 2 times cos sine of theta minus phi by 2. So this is equal to 0. That implies, so 2 cos theta plus phi by 2 times sine theta minus phi by 2 is 0. So either cos theta plus phi by 2 is 0. So this term is 0, or sine of theta minus phi by 2 is 0. So you can write theta plus phi by 2 is of the form 2n plus 1, because cos theta is 0 implies theta is of particular form. Here theta plus phi by 2 is 0, so you write it as that. So sine theta minus phi by 2 is 0, that means theta minus phi by 2 is of the form n pi. So this we are just copying from the recap. Where n is an integer. So this would imply you multiply both sides by 2 and then you get 2n plus 1 times pi, and then you subtract phi from both sides. So you get theta equals to 2n plus 1 times pi minus phi. Similarly, you multiply both sides by 2 and then add phi to both sides. So you get 2n pi plus phi. Okay, so you have minus here and plus sign there. So let us resolve this. So 2n plus 1 is an odd number. So now things are easy. 2n plus 1 is an odd number, and here 2n is an even number. So you can replace 2n plus 1 and 2n with just n, because you are covering all odd numbers and all even numbers. So instead of writing 2n plus 1 and 2n, you just write n, because n will also cover all odd and even numbers, because numbers are only of two kinds, odd and even. So we want to have that minus sign taken care of. So we write minus 1 raised to the power of 2n plus 1. Since 2n plus 1 is odd, minus 1 raised to the power of an odd number will always give you minus sign. So here we write minus 1 raised to the power of 2n. It will always be plus 1, because minus 1 raised to the power of an even number is always plus 1. So we resolve this minus 1 and plus sign. Now rather than writing even and odd numbers, you just write n. Because numbers are only of two kinds, even and odd. So if you have both even and odd, so you can write, so theta could be odd times pi plus minus 1 raised to the power of n times phi. So instead of writing 2n, I have written n. Instead of writing 2n plus 1, we have written n. So this is it. Yeah, so you just need to understand that theta could be of the form odd times pi plus minus 1 raised to the power odd times phi, or even times pi plus phi. Second theorem, cos theta equals to cos phi would imply theta is of the form 2n pi plus minus phi, where n is an integer. So you write left hand side like this, cos theta minus cos phi is 0. Then you write down the formula of cos theta minus cos phi, which is given as minus 2 sin theta plus phi by 2 times sin theta minus phi by 2. So either sin theta plus phi by 2 is 0, or sin theta minus phi by 2 is 0. Yeah, now we write down the formula. If sin theta plus phi by 2 is 0, this should be equal to n pi. Yeah, so that would imply theta is equal to 2n pi minus phi. Here again this would imply theta minus phi by 2 is equal to n pi. That implies theta is equal to 2n pi plus phi. So you combine both these results. Just like in theorem 1, you combine both the thetas. You get theta equals to 2n pi plus minus phi. So theorem 3 concerns tangents. So before we write the theorem, we need to recall that tangent theta and tangent phi are defined as sin theta by cos theta. So let us write this down. So these are defined as sin theta by cos theta. So the denominator cannot be 0. Yeah, the denominator is 0, then we cannot even define tangent. So for the theorem to hold, we have to have cos theta not equals to 0. That means theta is not equal to 2n plus 1 times pi by 2. So theta cannot be this. Similarly, phi, theorem concerns tangent phi, and cos phi cannot be 0. So phi also cannot be 2n plus 1 times pi by 2. So what is theorem 3? If tangent theta is equal to tangent phi, this implies theta is equal to n pi plus phi. Where n is an integer. So let us write down the proof. So we have tangent theta minus tangent phi is 0. So we just write down tan theta as sin theta by cos theta and tangent phi as sin phi by cos phi. Yeah, now we just expand out the left hand side. So cos theta cos phi, you take a common denominator. You get sin theta cos phi minus sin phi cos theta. So this you can now immediately notice that the numerator is a formula for sin theta minus phi, and denominator is cos theta times cos phi. So we have already seen initially that we have said that cos theta should not be 0 and cos phi should not be 0. So this equation is 0 only if sin theta minus phi is 0. That implies theta minus phi is equal to n pi, or theta is equal to n pi plus phi. So I've already made so we have reached the end, but I just want to make one more point. We have already made a remark about this. So we say the theorem is valid only if cos theta is not 0 and cos phi is not 0. Because only then tangent theta and tangent phi will make sense, and that will hold only if theta and phi are not equal to 2n plus 1 times pi by 2.